So the tree-based models involve stratifying or segmenting the predictor space into smaller regions. So as shown here, this involves segmenting the predictor space into a number of simple regions. For simplicity, we keep these regions rectangular. So tree-based methods are simple and useful for interpretation. They can be used for classification as well as regression. Here we have shown a sample tree with notations. So vertical lines here are called branches. Dots are nodes, which could be internal nodes or terminal nodes. Now let's see what are the steps involved in building a tree. We will first see the regression tree. In step 1, we first divide the predictor space into j distinct and non-overlapping regions as shown here. Now you may ask, how do we create these regions? So for creating these regions, we use recursive binary splitting. In recursive binary splitting, all the values are lined up and different split points are tried and tested using a cost function. So we split the predictor space, that is set of our variables x1, x2, etc. using a cut point that minimizes the below equation. Now as given in the equation here, y hat r1 is the mean response for the training observation in region 1 and y hat r2 is the mean response for the training observations in region 2 and so on. So we keep on splitting the predictor space into more regions until a stopping criteria is reached. Let's say the stopping criteria is that the region contains values no more than 5 observations or any other user defined criteria. So that is how splitting is done. Now once the split is created, in next step we use every observation that falls into the region Rj. We make the same prediction, which is simply the mean of all the response values for the training observations in Rj. So let me explain this with the help of an example. Suppose we have data of baseball players. We have their salaries, number of years that they have played, and number of hits that they have hit last year. So we will use this data to predict the salary of base players. So as you can see, salary is a dependent variable and we will predict the salary based on the hits and the number of years. Let's say after performing step 1, we created our first region which has a cut point at as 4.5 and has divided the data into two parts. That is AR greater than 4.5 and AR less than 4.5. Then we created another region similarly. Now the region is further divided based on the number of hits as shown here. So our tree will look something like this. First split is based on the variable years. The players who have played less than 4.5 years will get average salary of 11,000. And second split is based on the number of hits. So players who have hit less than 118 hits in last year will get 18,000 as an average salary. And the players who have hit more than 118 hits will get average salary as 24,000. Now these salaries are the average salaries of the respective regions. And any value falling in this region will be predicted to have these mean values. So that is how the tree is created. And then we use these trees to make the prediction. Now that we have built a tree by using the training data, so the next task is to check how will it perform on the test data. A complex tree built on training data may overfit. Recall overfit means high variance and low bias. Or a short tree may not yield good results, which means it will have low variance and high bias. So a better way to address this is to build a very large tree and then prune it to select the best subset tree. So for this purpose, we use a cost complexity non-negative parameter, which does the trade-off between subtrees complexity and its fit to training the data. So basically you can say that it is bias variance trade-off. Then apply cost complexity pruning to the large tree in order to obtain a sequence of best subtrees. Then we obtain subtrees as a function of alpha, so that as we increase alpha, it will penalize the subtree containing more nodes. Now you can just skip the math and understand the process. We will not be doing this manually anyways, and R will be taking care of all this, but I am just giving you the background, how things are being worked in the background. After this, we'll use k-fold cross-validation to choose the best tree. Now, k-fold cross-validation is a type of cross-validation, and like CV, it is used to select the best value or model. We will learn this in detail in a later video, but for now just understand that CV is used to select the best value or the best model. So that is how a regression tree is built. Now that we know how to build a regression tree, let's see how to build a classification tree. A classification tree is built in a similar way as a regression tree. So here to create regions and grow the tree, we use classification error rate instead of RSS. The formula for classification error rate is shown here. Here row head mk is the proportion of observations in the mth region which are from kth class. So if you subtract it from 1, you will get the proportion of observations which are in the mth region but do not belong to the kth class. Hence they are called as misclassified and will contribute to classification error rate. However, it turns out that classification error rate is not the best way for growing a tree. So in practice, two other measures are preferable for growing the tree. First is the Gini Index, and the formula for it is shown here. And then second is the cross entropy. Again, the formula is given here on the screen. Now a small value of Gini Index or cross entropy shows the node is pure and contains observations predominantly from the same class. So our goal while growing a tree is to minimize Gini Index or the cross entropy. So that is how we build a classification tree.